Did you know that most students find trigonometry easier once they learn about complementary and supplementary angle identities? With years of teaching experience, I found simple geometric ways to explain these concepts so that you can easily remember them. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes for you to highlight the important concepts and to fill out the answers to the examples that we're going to do. Let's begin by understanding how two angles can be complementary or supplementary angles. Angles alpha and beta are complementary angles if alpha plus beta is equal to 90 degrees or pi over 2. For example, 30 degrees and 60 degrees are complementary angles because they add up to 90 degrees. Angles alpha and beta are supplementary angles if alpha plus beta is equal to 180 degrees or pi. 30 degrees and 150 degrees are examples of supplementary angles because they add up to 180 degrees. We're going to look at complementary angle identities from two different geometric perspectives. Let's first look at the unit circle. Every point on the unit circle can be written as cosine theta, sine theta, where cosine theta and sine theta form the legs of this right triangle. On the right, I've enlarged our triangle so that we can see the angles better. The angles in our triangle are theta, pi over 2 minus theta, and our right angle. The sine of pi over 2 minus theta is equal to the opposite divided by the hypotenuse, which is cosine theta. Cosine of pi over 2 minus theta is the adjacent side divided by the hypotenuse, and that's equal to sine theta. Let's now look at the graphs of sine and cosine. We can see that sine of pi over 2 is equal to cosine of 0. And cosine of pi over 2 is equal to sine of 0. These are exactly our complementary angle identities when theta is equal to 0. The graphs of sine and cosine are shifted by pi over 2 units or 90 degrees. Similar to sine and cosine, there's a complementary angle identity that relates the tangent function to the cotangent function. The tangent of pi over 2 minus theta is equal to cotangent of theta. I've listed all the complementary angle identities in this green box so that you'll have them all in one place and can refer back to them. Let's now walk through an example problem so that we can see how we can use these identities. We're given that cosine 60 degrees is equal to A and sine 30 degrees is equal to B, and we're asked to show that A is equal to B. Let's write down what we're given. A is equal to cosine of 60 degrees and B is equal to sine of 30 degrees. Our complementary angle identity tells us that cosine of theta is equal to sine of 90 degrees minus theta. Let's let A be cosine theta and plug in 60 degrees. This is then equal to sine of 90 degrees minus theta, and we plug in theta as 60. So we get sine of 90 degrees minus 60. This gives us sine of 30 degrees, which is equal to B. And we've shown that A is equal to B. Let's take a look at this unit circle so that we can see graphically how cosine and sine of these complementary angles are equal to each other. Our complementary angles are 30 degrees and 60 degrees. And we can see that cosine of 60 degrees, which is this distance, is equal to sine of 30 degrees, which is this distance. Let's now learn about supplementary angle identities. Our two supplementary angles are theta and pi minus theta. On our unit circle, cosine theta is equal to x, and cosine of pi minus theta is equal to minus x. So our supplementary angle identity is cosine pi minus theta is equal to minus cosine of theta. In a similar way, sine theta is equal to y, and sine of pi minus theta is also equal to y. So our supplementary angle identity is sine of pi minus theta is equal to sine of theta. When we look at the graphs of sine and cosine, we can see that sine of pi is equal to sine of 0. We can also see that cosine of pi is equal to minus cosine of 0. Cosine of pi is equal to minus 1, and cosine of 0 is equal to 1. These are exactly our supplementary angle identities when theta is equal to 0. Similar to sine and cosine, there's a supplementary angle identity for the tangent function. The tangent of pi minus theta is equal to minus tangent of theta. I've listed all the supplementary angle identities here so that you'll have them all in one place. Let's see how these supplementary angle identities can be applied to an example problem. We're given that sine 30 degrees is equal to A, and sine of 150 degrees is equal to B, and we're asked to show that A is equal to B. We'll start by writing down A is equal to sine 30 degrees, and B is equal to sine of 150 degrees. Our supplementary angle identity tells us that sine of theta is equal to sine of 180 degrees minus theta. We'll let A be equal to sine theta, and we'll plug in theta is 30 degrees. That gives us sine theta is sine 30 degrees. Using our supplementary angle identity, this is equal to sine 180 degrees minus 30 degrees, which is sine of 150 degrees, and this is equal to B. So we've now shown that A is equal to B. Our unit circle graph shows us that the sine of these supplementary angles are equal to each other. Our supplementary angles are 30 degrees and 150 degrees. And we can see that the sine of 30 degrees given by this distance is equal to the sine of 150 degrees given by this distance. I hope that you now have a better understanding of complementary and supplementary angle identities and feel more prepared to use them in future problems.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.